Hey everyone, thanks for joining us today. We'll get started in a few minutes. Hi guys, we're going to start in 2 minutes. Hi everybody, and welcome to today's webinar, Advanced Strategies for Testing Responsive Web. I'm Austin. I'll be running everything in the background today. And before we get started, I'd like to go over some housekeeping. We're recording this entire webinar, so after the webinar takes place, in the next day or two, we'll send you the recording and slides. We have a live poll that will come up throughout the webinar, so please participate in that. And we also have an end of webinar survey. We'd love to get your feedback in that as well. We have a questions panel, so please ask your questions throughout the webinar. We will save some time to answer them at the end of the webinar. So now I'd like to introduce our panelists. We've got Aran Kinsbrenner, Uziah Lon from Perfecto, and Akrit Prasad from Athlete Tools. Welcome, guys.
Hi everyone. Thanks for joining this exciting webinar with our friends from Amplitude. I'm Eran Kinsbrunner. I am the director and mobile evangelist at Perfector. With me I have Uzi Eilon, CTO for Perfector. Hi Uzi.
Hi, how are you, Eran?
Good to have you in this exciting webinar. Plenty of guys online interested in this exciting topic. Ayakrit from Amplitude, how are you?
Good. Thank you, Ron. Thank you for having me. Hello, everyone. Appreciate the chance to be able to share, more about Amplitude and about responsive web design.
Perfect. So for those of you online who have attended previous webinars on responsive web, so we are actually going to take in this webinar an advanced approach to responsive web and build on top of previous sessions that we have done. We are going to talk about coverage recommendations for responsive web. We are going to talk about automation at scale and why it's important, or what are the challenges around responsive web at scale. We are going to work with and show with Amplitude how to be successful in visual testing for responsive websites, and we'll conclude the webinar with some angle about performance testing for responsive websites using HAR file, HTTP archive file analysis. And as Austin mentioned, we're going to run a poll just in between the sessions. We'll appreciate your feedback and participation. So let's dive in. In a nutshell, just understanding not what is responsive web, but why organizations are moving towards responsive web. The adoption is growing as we speak. Most of the enterprises are either already in their journey to responsive web or transitioning to responsive web from the www or the m.dot website. And there are few attributes that contribute to the transition or to the adoption. One of them is the digital transformation. Organizations are interested in showing the seamless user experiences across all different sizes, form factors, devices, tablets, websites, desktop browsers, and so forth. And to do so and to be successful, the site needs to be responsive. Otherwise, and we will show, even with responsive, it's challenging. But if it's not responsive, you simply cannot scale and provide a seamless user experience. In addition, there is the efficiency and the code maintenance. And with one code, it's obviously easier to maintain your product compared to a native app or an m.dot that consistently changes and you need to sustain. There are also business drivers to responsive web. You want to have a larger outreach globally, regardless of the networks and the locations, and obviously a website provides this kind of benefit. Before we drill down into coverage aspects and the entire content, I just want to highlight something that I am seeing recently in almost all the leading desktop browsers, Edge, Firefox, and obviously Chrome. We are seeing a great, I would say, advance in the development tools that these desktop browser manufacturers are offering the market. They are allowing developers and testers to do accessibility audits, performance audits, network traffic analysis, and some other capabilities. And I just think that some of these are already integrated in Selenium, but even if they are not, developers and testers have opportunities for fast improvements already from within the desktop browsers for the responsive website. So if you haven't checked these capabilities already, it's kind of recommended to do so and see what you can already leverage today. We talked about the drivers for responsive web, the scale. You want to reach any desktop browser, any smartphone and everything, but the variance of the desktop browsers actually also causing challenges. And as you can see in this Wikipedia site, and I won't take too much time here because Uzi has built an amazing demo through this webinar, but you can see already that different browsers even for responsive website, behave differently across the different workflows and navigation. So testing on the right browsers and devices is obviously key for success for your responsive website. Responsive website also means that you have to do proper UI optimizations. Obviously, the different screen size respond to the target platform on which you are running the website. However, if you look at some of these examples, and Akrit will also show some of his collection, you see that a responsive website look quite different, and the scaling of the tables, text, and everything doesn't really look okay on devices and desktop browsers. And this is why you need to have a proper coverage strategy for responsive website. And this is, what Perfecto, one of the things Perfecto is providing as part of the cloud, our cloud offering is factors, is the ability to get always the right lab customization, configuration for both web and mobile. And the way we are looking at the coverage for websites, for responsive websites, is as follows. If you have the web, we want to include for responsive website both desktop web browsers and mobile devices. For web, we recommend 3 layers of coverage, starting from essential to enhanced and extended. The essential takes the latest Chrome on Windows 10, the latest Chrome on Mac OS, and so forth. So we recommend at least top 10 browser permutation if you want to have the basic web coverage. For mobile, we have the top 10 smartphones and tablets, which we always recommend as part of the Factor magazine.
Eran, I just want to ask you a question here. I'm seeing that you mentioned Chrome Beta and Firefox. Can you say why it's so important to test on the beta, and if you have any example of errors that one of our customers got?
Yes, of course. So 2 reasons to test on the beta versions, like also on mobile. Web isn't different. The desktop browsers are being populated and distributed to the users automatically. You know, when you close the Chrome browser, you open it again, boom, you have the latest version. So not testing since the beta exposes you to risks of, not finding the bug in advance. The beta also exposes you as developers and testers to different, I would say, features. I can point one, I think in Chrome 59, if I'm not mistaken, Google changed the entire UI layout, okay? They changed specific UI layout that maybe didn't create immediately glitches in your application, but you wouldn't know unless you tested. So you don't want to wait for GA to find all the changes in the UI. And oh, by the way, as mentioned earlier, both the desktop browser manufacturers provide developer tools. You can actually get a first preview of these tools like code coverage analysis, network traffic analysis, already from the beta, so you can actually enhance your testing coverage from beta versions and expose a higher quality when this browser is becoming GA. So I think at the end of the day, it's like on the mobile device, on the mobile OS version, when you get access to a beta, you have higher chances of finding issues and regression in advance. Bottom line, maybe the table looks scary, but that's the market. So if you look at the top, it's a very simple math here. And if you refer to the previous slide, so we showed what are the top desktop web browsers that we recommend in the essential bucket. We have the top 10 devices that we recommend continuously also as part of our magazine. You can get this magazine online on our website. So you have the top 20, the top 47, and the maximum coverage for responsive websites that you can, aim for would be 65 desktop browser permutation and mobile devices, OSs, tablets, and so forth. This will give you the highest possible coverage and risk mitigation for your responsive website. And I think that if you look at the 2 slides ago on my different bugs on iPhone X and the iOS 11, and we will see some bugs that Uzi is going to highlight in his responsive web demo, as well as Akrit from Applitools. you will see why coverage is so essential for responsive web testing. So before drilling down into Uzi's session, let's run a short poll, because testing responsive web, it's not just about coverage, it's also about the different testing types that you want to make sure you are executing, starting from accessibility, that is becoming critically important, visual testing for responsive, how the layouts and the navigation looks like in different screen sizes, different screen orientations, doing functional testing, obviously, performance and security, and others.
So we started to get the results right now. And actually, I'm not surprised, but most of the people mentioned that the functional test at scale across mobile and web, this is the biggest check. I thought accessibility also will find us, because right now, because of the change of the legal part of the accessibility, we got a lot of requests from our customers to focus on accessibility and to add tools, because most of the accessibility tests today done manually. We're going to talk about it in the future, but right now, and I think you are on the right place, because we're going to talk about how to scale during your execution of functional testing.
So yeah, actually our two demos today covering functional testing at scale and visual testing by Applitools, and these are the most important or challenging testing types that you guys online voted for. We will conclude also with some performance and security demo by Uzi, but again, thank you all for voting. It's very insightful. And with that, Uzi, I will hand it over to you to start talking about the automation at scale.
So let's talk a little bit about how to build strong automation, how to build automation that I can execute it every day on all of the 80 or 40 devices that Eran just mentioned and get real results. So what are the important things? So first of all, in order to have a stable automation, you cannot run just a static main from Java. It doesn't work. You need a framework. And the framework contains a lot of things, but the most important thing that you need to have in framework is one, parallel execution. Remember, we are going to talk about a lot of devices. We don't have a lot of time. We need a parallel execution. I will show you and talk a little bit about the different parallel execution options. Another thing is reporting. So let's talk about 100 test cases, 50 devices. We have large number of results. How can you find the issue? That's something very important as well. Another thing that your framework needs to provide is actually easy way of scripting. Some people will feel comfortable with Java, others with JavaScript, but some will feel comfortable with BDD. And actually, and correct me if I'm wrong, Eran, we are seeing more and more BDD in the market lately. I don't know why, but I see a lot of big projects focus on BDD, especially in responsive web and Selenium.
So I think that BDD, provides, I think one of the benefits of BDD, other than the skills that are, I would say, lower in order to get started with, I think that it's the alignment that it, facilitates between the different parties in the feature team, developers, testers, the business. So all the owners of the project speak the same language, so there are less vague things.
That's a good point.
One of the things which attributes.
That's a good point, and I can share that some of our customers actually gave the product owner and the business guys to create a test, so they are using the BDD statement in order to create a test. So this is really, really powerful. It gives the ability to have end-to-end testing based on the important things for the customer. Another important thing is the retry. Let's say something happened, you want to have a retry, or utils, I want to scroll down, so I don't want to do it. But this is very common usage. I can show some example about that, but I want to focus on the three important things, which are the parallel execution, reporting, and the easy scripting. And another thing, if you want to have an automation that scale, is you must have a cloud. Any cloud, but you must have a cloud. You cannot run it on the local PC. First of all, you need the cloud that gives you all the resources, web and mobile together. One cloud, one execution session, one reporting system. it needs to be secure. It needs to support all the standard automation platforms. Selenium and Appium, we are seeing it's very, very common, but in native application, we are seeing more and more XUI test and Espresso. By the way, next week we have a webinar that we are going to focus on XUI test and Espresso automation. Okay, so I will continue and talk a little bit about the parallel execution. How does it work? Think about the following. I have my script. It can be 1 or 10 or 100. The CI process is the trigger. It's going to execute the script. And when I execute the script, let's say I have one script, I want to execute it on all the different devices, or on the different browsers. So the parallel execution means that I want to have one screen runs on all of my available resources. Again, resources can be mobile or web. But let's say that I have my test, it takes 6 hours, and I want to execute it only in 1 hour. Why? Because this is my execution window. That's what I have. I have 1 hour. How do I solve it? So when we're talking about parallel execution, we have another layer of parallel execution. Think about browser. We can have more than one in a cloud. So I will double my environment by 6. I'll have 6 permutation of each browser, 6 permutation of each device. And when I'm going to run my test, it's going to reduce from 6 hours to 1 hour. So the parallel execution and the framework allows you not only to execute one script on multiple devices, but also to split the script and execute different scripts on the same device or resource permutation. So that will help you to reduce the execution time. So we have a lot of execution. We talked about it. We have like a lot of devices. How do I analyze the report? And that's something very important. To have a very strong reporting environment, I will show Perfecto environment report environment tools. It allows you to understand where are the problems. Today in the demo, you will see exactly how can I drill down immediately to the problem. Think about it. You are going to run your test, you reduce the execution time to 1 hour, but then you have only 10 minutes to analyze the results. And if you have 20 errors from 8,000 execution, it will take a lot of time to find it. So today I'm going to use 2 demos. The first demo will be a functional testing demo. I'm going to use JavaScript. I know a lot of you using JavaScript. I also use Protractor Cucumber solution. It allows me to run both BDD and Protractor. Protractor helps you to have strong automation test on JavaScript environment. And the other demo that I'm going to run will be a HAR file, and for that I'm going to use a Java framework, a Quantum framework, which is open source released by Perfecto, which allows you to create some automation. So today we're going to focus on 2 different platforms because I want to show you and to remind you. It's not important which framework you are going to select. It's important that you are going to select a framework that provides you all the capabilities that I just mentioned. So this is the demo. So we have a demo. We are going to Wikipedia site, and I'm going to execute one script on my machine. First of all, I set up the local execution. I have like Chrome and Firefox, and by the way, we talked about how easy or hard it to set it up. It took me like a day to set up, to get all the right driver, to get all the right browsers. By the way, something that happened to me, I wanted to execute it on the previous version of browser, but I couldn't because I installed the newest one. So it wasn't easy to set it up. And after that, what I'm going to do, I'm going to take the same script and execute it on 3 devices. So you'll see how nice, on 3 devices, sorry, I'm going to use 3 scripts. I'm going to execute it on 12 devices in the cloud. So you'll see how nice it runs on both browser and mobile. And at the end, we're going to go to analyze the results and see if we'll find a bug in the execution. So let's start with our script. So this is the script. As I mentioned, we are using a BDD. What you can see here, this is my BDD. Something very important, screen size, resolution, change it as part of your test. So I'm running the test. I'm going to eBay. I'm then going to, in this case, I'm going to different language, which is Spanish, and then I'm going to press some buttons, and I have the same test run twice, and here what I'm going to do, I'm just going to change the screen resolution. Another test is the donate. I want to donate to Wikipedia. You can see here, I'm going to donate, I'm enter the value. So we have a functional testing, we have a language testing, and we have the standard booking testing. So I created three scripts, and you can see that I gave a different tag to each script. As I mentioned, in my framework, I'm able to execute it on my local device and on the cloud itself. So let's start to execute it on my local device. And this is what I want to do. I want to execute it on the local device. Which devices I'm going to execute it on? I'm going to execute it on Firefox, on Safari, and on Chrome. So I have three browsers installed on my device. So let's go to the execution area. So this is the local. So I'm running my test. I would like to execute it on my local machine. Remember, this is the parameter, and I'm going to run it on all the browsers that I just mentioned. What happened right now, the script is started to run, and in a second you'll see more and more browsers open on my screens. So let me show you all of my browsers. So you can see immediately both of the Chrome being open, both of the Firefox, and remember, this is all locally. So suddenly all the browser wants to go through the Wi-Fi that I have. So it takes a lot of time to start it. Some browser will be stuck. It will take time, and the script starts to run, and it's run. But it takes time. It's not reliable. It's not fast. You see, this is actually executed donate, and only now the Firefox has been open, and only the Safari still did not open. This is what happened when you try to run all your tests in your local environment. Remember, local environment, you have limited resources.
And just a comment, we're talking about a responsive website, and you're just showing 3 local browsers that challenge. You didn't even start connecting, via ADB or something, real mobile devices.
That's a very good point. So
just the browser.
That's a very good point. So if I wanted to add more browser, I need to add the local driver. I need to reset the Appium, the Selenium servers once in a while because of the memory, to clean the memory and to clean that. So it's really hard to maintain. It's really nice demo, by the way. So it's run. I have all the results, everything been executed from my framework. I really like it, but it's good for demo. It's not, it cannot be a stable CI process. And let's talk a little bit about how to do the stable CI process. So what I want to do is to execute the same script that I have. So I'm not going to change anything, and I'm about to run it on Perfecto mobile cloud. So the only thing that I need to change is actually to say, okay, I don't want to run it on my local machine, but I want to run it on Perfecto Cloud. But, okay, so we can execute it. So we're running the same test on Perfecto Cloud, and it's about to start. So what I'm doing right now, I'm going into Perfecto environment, and what you will see in a second is that the devices will be start to open. So the iPhone is the first one that's been opened. In a second, you will see the Samsung will open. So I asked to run it on different browser and different devices. We also set up a virtual machine. So now all the virtual machines is about to open again. So we have the Chrome and we have the Firefox, and all the machines will open automatically. So I have one script, and immediately it's been executed on all the different devices. And something really nice here that you can see, I execute more than one machine or one instance. So for example, I have 2 Firefox. The one Firefox will execute test number 1, the second one test number 2. So you can see right now I have one script that executed on all of the environment on the same time, different script runs on the same instance, and at the end, when the script is ended, the machine's been closed, another machine's open, everything maintains automatically by the cloud. I did nothing in order to do that. I don't need to think about what are my available resources. I don't need to think about how to run it. And you can see how easy devices start and stop, browsers start and stop automatically. The donation, this is the donate script that runs on this area, and the local searching run on this machine. So you can see different scripts, different machines, and everything being executed in parallel. So again, I just want to remind you, two types of parallelization. One parallel between devices, one script on all the devices and the browsers, and second parallelization is between same instance of machines, different scripts in order to end it fast.
I love it, Uzi. I think that what we are also seeing here is also the leverage, as you mentioned, in your BDD script of different screen sizes and layouts, which provide you high coverage for the responsive web. And I think that once we drill down into the report, you'll actually show something very interesting that you found.
Exactly. So the script is ended. I don't know what happened. I know that a lot of things been executed. And I want to understand what happened. So I went into the report. By the way, this is my report in the environment. I have the list of the execution. I can see that I have some error. I want to understand where are my errors. Why do I have an error? So I can drill down to each of the execution. That will be one option. But the other option is the heat map report. And what I did here, I actually analyzed it based on the script and the browser. So I can see that the ESPN large size script executed on Chrome and Firefox without any problem. Go to Wiki. This is the script that go and look the donation after that. It's been executed without any problem. But here, the Spanish test on a small screen with a mobile device, I can see that it works on Firefox, but I have a problem with Chrome. All the execution with Chrome being ended with error. So what I want to do now, I want to drill down to the execution itself in order to understand where are the problems. And immediately I can see that the problem not happen only on the latest version, but also on the beta version. So I would like to drill down and see what is the problem. And I can see that it cannot find an element. And if I'm looking on the screenshot side, I can see immediately why. Because I just see that there is an override of objects. So the screen looks bad. The script is not available. So suddenly the test cannot be found, the element cannot be found, and the test ended with error. So immediately I know I need to focus on the Chrome. I know that I have all the scripts runs on all the other devices. And I think that's result that showed us that one script can, or one site can look different on different browser. It's a good way or a good example, and it's the right time to move to Akrit in order to talk a little bit about visual script and visual tests done by Applitools. One last command that if you want to use Perfecto and Applitools, part of the cloud, it's already embedded. So just say, I open, I take a picture, and that will be the only thing that you need to do.
Thank you, Uzi. Akrit, we're handing it over to you, but while we are transitioning, we're getting a lot of questions in the background. One of the questions, Uzi, was actually, are you actually demonstrating real devices? I think it's known for like a long while. We only have real smartphones, tablets in our cloud. So everything that you have seen right now is all real devices, Android and iOS smartphones. Thanks. To you, Akrit.
Okay, thank you, Ron. Thank you, Uzi. Can everyone see my screen? I think I got presenter here, so I want to make sure that it looks presentable.
Yeah, just put it on full screen. We can see it.
Okay, great.
Thank you.
Okay, so the next segment is to get into the visual testing piece, responsive web design. So I'm here on behalf of Applitools to talk a little bit about how we look at building a product for visual testing responsive web designs, and what is kind of the strategies for in the field of visual testing. What are some strategies for responsive web design applications? So before I get into that, let's take a quick overview of what really is visual testing. The way we define it is really, it's a testing activity that you're aiming to validate that the user interface is appearing, and the keyword being visually perfect to users. So it's really, in another way to put it, is kind of testing the look and feel of your application. So it's the first thing that your users will kind of interact with, get acquainted with as they're using your application, and in that sense, they'll actually have a pretty strong impression of your product based on how visually perfect it appears. Now, when you look at responsive web designs, the more common, very commonly the piece that actually makes the design very responsive is this kind of window width. And then when the width changes, I'll actually kind of go into a quick example here. When the width changes, that's when the site kind of emulates the behavior of responsiveness. So if you look at github.com here, and we'll actually show a quick demo of that later. GitHub.com here, you see that this is kind of your standard laptop view. Now, if you start kind of shrinking this viewport at the screen size, you start to see that there's a shift, right? So now there's this hamburger button, and the layout has changed. And as you kind of keep shrinking it, you'll see there's another shift here. And then there may be another shift. So in this case, GitHub, for example, has 4 different breakpoints at various different width levels where the actual design of the website changes, and hence, it's essentially is a true responsive web design. So we go back to, that is a very key piece of, making a website very responsive. And so, this is kind of what I just demonstrated here. But that it allows you to actually be able to build a web page without having to code it in many different layout modes, making it responsive. But there are some challenges that come with that. So I mean, one main challenge is that there's different interfaces which will have different interactions. So as you notice that in the GitHub example, as we shrunk the screen, there was this hamburger kind of navigation menu change. And so now the user interaction is going to be a little different to be able to navigate to newer pages. So that interaction poses different challenges for making sure that the visual appearance of your pages and doesn't change with any changes you make on that screen, for example, for across the different viewports. Another issue on top, in parallel to that, is the image scaling and navigation menu. So you notice that as we start shrinking the view and the width of the page, certain image elements actually start to get smaller, certain things will move, and obviously there's a navigation piece. So that's something to keep in mind. This does introduce a slightly higher probability of possible visual bugs happening from these changes, because you're making a change in kind of in one view, and then you don't know how it may impact all the other views. So you have to kind of be more cognizant of that impact and be able to test that on a continuous basis so that it doesn't break the user experience for anyone. And that really takes me to the last point, which is there's a greater need for this visual testing, so that your customers always have a very positive and impactful user experience. So what are some kinds of visual bugs that we see? I mean, many times there are layout bugs related to styling. We do see bugs around content and the context that's being shown. There's coloring bugs we'll see sometimes. So in a new release that's being pushed out, maybe the coloring and the layout may change, which could actually impact users and their ability to navigate this service. And then there's obviously the more usability-related bugs than navigation-related bugs. So with responsive web design and the form factor and the screen space changing, with that screen real estate change, you may have new icons and buttons that come in place that actually allow users to navigate, but then the navigation experience changes as a part of that. So you want to make sure that that behavior is consistent across new releases, and if there is an actual change, you're aware of it. It's not a bug or regression that's introduced from a new release change. But there's also a piece of, when you look at visual testing, you want to have a solution for more effective visual testing. I mean, there's you could compare two images and do bitmap comparison, but oftentimes you may run into false positives that may not be necessary for, that may not actually be true bugs, because they may not be things that users notice or impact their user experience. These are things around anti-aliasing, pixel brightness, letter positioning, even image scaling. Those are things that are true false positives in many user experiences, and any kind of a very non-robust, kind of straightforward bitmap comparison will catch those things and tell you, hey, these are all visual bugs, and so that'll kind of make your workflow around visual testing a bit inefficient without having a robust engine to catch those things. And then the other piece is, the web is kind of moving to become more dynamic. It's going to have more moving elements. That's kind of a transition that we're seeing to allow companies to build products that give users a very personalized user experience. So with that, it becomes even more important to allow to build kind of visual testing framework in your test suite. So user experience is always, it's always very high. So what are some of these visual issues look like in production? So I mean, these are some examples we've taken of different web, products that are heavily used products in the market, where there's layout bugs, there's rendering bugs. I mean, these things will impact your users from being able to navigate the product and being able to actually, I mean, there's obviously implications on the functional side and other areas, but on a visual end, if the user can't really make sense of what's going on here or navigate, then they'll have a much harder time being able to use your product. And so that leads to the next area, which is, really the impact is a negative customer experience. I mean, today there's customers have such a high expectation for the user interface and their digital experience when they use the products, that if they have a negative customer experience, they're more likely to go somewhere else and use something that's competitive. So you want to make sure that they always have very positive experience. Obviously that will impact your brand impression if there's a lot of bugs. And it does eventually trickle down to business impact and your business growth and bottom line. So you want to make sure that if there are buttons that are being hidden by coloring and things, users may not be able to click on certain things to add to cart, for example, or different kind of application use cases where if they can't navigate your service, then they'll not be able to essentially book the orders or be able to use your product the way you're wanting them to use it. And it's something that is potentially more likely in responsive web designs, because when you look at, you have responsive web designs to give you that productivity of being able to build a user interface, a screen page, and then being able to have it render really responsively on different kind of devices and browser viewport and form factors. But it may be that there may be a bug that could occur based on changes you're making, so you want to be able to test that robustly with kind of a continuous integration. So I think the next piece I want to touch on was, really visual testing and testing as in general is really about interaction and validation. So, the interaction is kind of the piece which provides input to the application, and validation is more on like verifying that the result output is correct, the page content is optimally, in this case, on our visual testing cases, optimally displayed in all browsers, devices, screen resolutions, operating systems, the way that you want the users to navigate and use the application. So with that, there's certain kind of tips that we recommend around like interaction, building an interaction. One is around like detecting the page layout within a page object. So, the best place to code a lot of these rules around the layout is in the page object itself. That way, if the rules update, you won't have to touch or update your test. And this will also allow you to, it'll help with building, browser and layout independent automation. So it's important to kind of build your interaction with that in mind. You also want to avoid creating layout-specific page objects so that you don't build a specific page for each layout of your application. The layout modes often share kind of a similar DOM and layout structure. The only difference often being around like styles, visibility, location of elements. So you want to keep that in mind, and you certainly want to many times avoid kind of using the window.innerWidth property to determine where the elements or button locations may be. So you want to obviously try to figure that out, figure out how to click the navigation button by the presence of the button instead of determining the page element location. And one of the main reasons for this is that if someone changes, for example, the breakpoint for the next view, and when you shrink the width, the view changes. If that breakpoint changes, then it will break your test, because if you're relying on window.innerWidth, then it's going to break that test. So those are, and I apologize for the numbering here. I just noticed that the numbering is not correct, but it should be 1, 2, 3. So validation, is the next piece, and I'll have a demo that'll kind of illustrate some of this, but just to get those kind of high-level points in. When you come around building the interaction, the next piece is, you run your test, and then you want to go and validate. So when you look to validate, you want to always prefer like full-page validations. There's 2 primary reasons for this. Full-page validations will give you a lot more coverage, and they require less effort to maintain in components that are specific. If you have component-specific areas that you need to find element locators and maintain them as the app changes, this will kind of make it a lot easier for you to kind of navigate that workflow. You also want to look at maybe focusing on lower layout boundaries if possible, because these are kind of like the conditions where you're likely to have kind of the ugliest UI and the most kind of possibly more bugs in the layout, and it's kind of a more dense and crowded screen real estate before the breakpoint where it switches. So if you test in this case and if you don't find issues there's the better chance that you probably won't see anything on some of the other layout viewports. And then you always want to, in visual testing, prefer real browsers and devices, because emulators sometimes can only support certain operating system versions, and they may not take into consideration certain hardware, and apps may run differently on, and visual representations may not be fully accurate as they appear in real browsers and devices. So you want to obviously have that true user visual appearance interaction when you do your visual testing, so that you catch the true regressions that might come up. So how does a kind of an automated visual testing workflow work? So, the way that this workflow kind of can bake into your integration system is, you driving the application test and taking screenshots. That's kind of how Apply Tools will kind of integrate with your system. So Apply Tools, for example, supports 35 different SDKs, and there's a Selenium, Appium, all kind of supported, all different versions of those, XCUI, Espresso, which are many different ones on the website that are listed. But essentially, you'll start using the SDK to build support with Apply Tools, and you'll add you'll add the kind of areas, the windows that you want to start taking screenshots of, the pages you want to hit on your application. And then once those images are taken, what Apply Tools will, for example, or a visual testing workflow would do is take those pages, scroll the page, stitch all the pages together, and then send them to a server where it can compare that with the baseline image. Baseline would be an image that's already taken up that screen from a previous release iteration to make sure that there's no visual regressions. If there's any differences found, you should be alerted to that, so that you can decide maybe it's a difference that you want to accept because you decided to make a valid change in the UI, or if it's a visual bug, you want to be aware of it so you can make the necessary changes before your customers start to see it. And based on that, you'll kind of update the baseline. And so it's important to be able to do all this kind of in an integrated fashion, so you see this, you can catch this, this behavior across many different form factors, devices, browsers. If you're doing localization testing, you catch it across the app. And you can do this through Jenkins or TeamCity or Visual Studio and different Team Server Foundation, so different kinds of CI engines. Apply Tools, for example, does support all of these as well. Before I dive into the demo, the other thing I wanted to add was having kind of an automated visual testing workflow. In a lot of ways, as you look to improve your release agility, it plays a big factor in that as well. And in many cases, it can save you 80–90% of your test time savings, because having to do this manually takes a lot longer and there's more error prone. Being able to do it automatically with an AI-baked engine, which is how in Apply Tools case is doing that, will give you that really very fast time to value, and being able to reduce time savings significantly, but also allow you a lot more test coverage, the breadth of the coverage that may be not possible to do manually. And then as the baselines and changes are updated, you could have that transparency and that visual validation changes that are happening, and you could see where the changes were made, when the changes were made, and who kind of approved those changes. So before I jump into the demo, this is a quick, we were going to demo with GitHub, and we found a bug actually when we were trying to set up a demo some time back, where you can see the layout here is completely changed. And so for users that want to, here's kind of when they had updated it, but initially this is what the bug looked like. And so if you're for a user that wants to actually go and check out features or go to the community, they can't find those buttons because they're all kind of superimposed on top of each other. So that causes usability impact, and that causes users not to be able to use your product. So these are the kinds of issues, for example, that visual testing can catch. So the example that I'll have, for the sake of time, it's a fairly small example. It's kind of a Java application that's using JUnit, Selenium, and then pushes the image SDKs to Apply Tools. And what we'll do actually is we'll go to GitHub's main page. We'll take screenshots of this page. We'll do it in 3 different responsive web sizes. So we'll kind of have one size here, then we'll kind of shrink the size and navigate that page for visual tests, and then we'll shrink it again and navigate that page. So and then we'll actually run this behavior on the GitHub main page, the features page, and then the explore page as well. I believe actually the business page. So let me go ahead and actually just quickly point my screen to the IntelliJ example. So as you can see, this is a very simple example that I put together. Basically, what we're doing is this is kind of using the Apply Tools SDK and building a simple Java example that will navigate to the pages that I just showed you on GitHub. Here's kind of a very simple command that says if you go to GitHub, we go to the home page, we go to the features page and explore page, and then you'll basically run this test. So if I go ahead and now run this GitHub test, let's go ahead and actually see if I can show the main screen. So you'll see that the test is starting. It's going to first resize to the proper width size. There's the 3 bits, and then it'll start scrolling the page and taking screenshots. And then later it'll start stitching those screenshots. And so the first view is this view, and then it'll shrink to smaller viewport width sizes to do the same test. And so this test will take a little bit of time to run because as you can see, it's taking a lot of these images and it's going to stitch them together. So while it's doing that, so now it's navigated to the features page. We'll go ahead and run that. And then while it's doing that, I'll actually navigate us to kind of what the end result would look like for the sake of time. So let me go ahead and shrink that in. Okay. So if I go back here, we have, so this is kind of, and this is essentially what the test would look like. So once all the images are taken, you can see here that the GitHub responsive web design demo example, there's 3 different tests that we run. We run one test on a viewport X, another viewport Y, another viewport Z. So the different viewports, and in these viewports, if you click on it, you can see that we went to the home page, went to the features page, and explore page. Now, in this case, when you drill into it, you can actually, it'll show you any visual regressions found. In this case, you could have run the test. Applitools allows you to run the test on many different modes, but you could have ran it on strict layout mode. In this case, we ran it on strict mode, so it's actually looking at content. When it looks at content, it may find issues, and if it's dynamic content, it'll often find things that, if the dynamic contents change, it'll alert you of that fact. So, so in this case, we obviously know that everything here looks great, so we would update the baseline. And if we exit out of here and move back to this view, here you can see this is an example where, I'll just let it quickly open. This is an example where you can see that, the dynamic content is being highlighted. Actually, so I moved it to strict. I'll go ahead and close this test. Okay, so there's a couple different modes that Applitools, for example, has, exact, strict, content, layout, but you can see that in in exact mode, you're looking at exact pixel level differences, so it'll kind of highlight all the differences, but a lot of this dynamic content is rendering the page differently every time you visit the page, so those will be things that will flag, but if you move to layout mode, then all of that will, essentially pass, the entire test will pass because the layout of the page hasn't changed at all. So with that, I just want to end on one last piece, which is, you in this case, you may want to test across, hundreds of different, or maybe dozens of different browser versions of viewports, operating systems. So if you wanted to run a more exhaustive test, you build that, you can run it, and then you can actually see a lot of analytics in the product that shows you that distribution of operating system, form factors, browsers, even by test assignment. Great. So I think that's all I had for the sake of time. I'll pass the screen back to you, I think, Iran.
No,
okay, and thank you very much, everyone.
Thank you, Chris.
Thank you, Chris.
Great demo, and we'll just move to the last part of this session. This is leveraging HAR file, HTTP archive file, to analyze performance, security, and other optimization of your responsive website. You can see your screen now.
Perfect. So what we want to do in the last few minutes of this webinar is talk a little bit about the HAR file. So what is the HAR file and why do we want it? So responsive web, remember, is the same code that runs on web and mobile. Web is bigger, mobile can be small screen. So different things should be seen differently on this different screen, but it's also related to the data that you are sending to the device. For example, images. On the mobile iPhone, I don't want to have big images. I want to have smaller images. On the web, I can have bigger images with better resolution. In web, I have a lot. In mobile, I have a lot of real estate area on my screen, so I can send like 20 pages. In mobile, I can have only 4 images. So these changes can affect the way that I sending the data to the client itself. So in responsive web design, you need to decide what is important, what need to be sent to the device itself. That responsive web page will take a lot of time to upload it on mobile devices. Why? Because all the images will download on the device itself. So in this example, I just went to target.com, and you can see that it's downloaded a lot of images, much more than needed, to all of the devices. So even if I'm on an iPhone users and I go to target.com, I get some images that I cannot see on my device because it's not part of my screen. That's one thing that we saw. But the other thing that we saw, because it's a mobile device and you can get the data, we can see that it sends the same command twice, one with the location and one without the location. Just waste of time. It just takes much more time. By the way, in this execution, it takes 3 more, it took like 20 minutes to upload it on mobile and just 12 on the web itself. So the differences are really, really big. So in order to do that, what I want to do is to show you how to get the HAR file. And to get the HAR file is a simple command in Perfecto Mobile. So I'm going to open Quantum BDD framework. I will go to target.com and download the HAR file. So how does it work? Let's go to the demo. So what we can see here, this is actually the script that I created. I decided to work right now in Java. Remember, in the previous demo, we worked with JavaScript and BDD. And here I said, okay, I want to have like classic JavaScript, Java code. So what you can see here that I'm getting the HAR and the management of all the driver and connection done by the framework. All I need to do is to focus on my test. And my test is really simple. I'm going to target.com. I'm looking for the search. I'm entering laptop, and I press the go button. And then I'll scroll all the way to the screen. But I have 2 more commands, get HAR file and close HAR file. So when I'm executing the script, I just run it right now. It's been executed on the cloud, so you'll see the device will be open in a second. So I open it on the Galaxy. You will see that the Galaxy will, or the target site will be open on Galaxy. The driver being open right now, and we are starting our test. We're going to target.com. We're looking for the search, entering the laptop, press the go button. Very simple script, and then we would like to scroll down all the way of this screen, and we see that it takes a lot of time to get all the elements. But I want to scroll down to make sure that all the elements arrive to the screen. And by the way, this is why I added the scrolling into the script itself. And at the end of the execution, I'm getting the HAR file. So if I'm going to report to Perfecto Mobile reporting environment,
needless to say, Uzi, this is target.com is the responsive website. Whatever you just executed needs to be executed on all the other platforms. So imagine you can get the HAR file across all different platforms and optimize both performance, load time, and others.
That's so true. And what you can see here, this is the script that I executed, and here I have a network file. The network file, I'm going to download it, and by opening it, you will be able to see that one of the files that I'm getting will be the HAR file. I'm getting a lot of other files. What is the pickup file, some logs file of the execution, but the most important thing for this demo is the HAR file. I decided to work with Charles proxy, so I'm opening the Charles proxy in order to see what happened during the execution. You can use different tools to analyze it. I really like Charles proxy because it gives you a very nice UI to understand what happened. So immediately I can see what happened. These are all the calls that happen when I execute my script. By the way, I can see immediately what is the sequence, how much time it takes to execute everything. So if I went to target.com, I can see that all the calls, how much time it takes to execute each call. Let's try to find something interesting in this HAR file. So I'm going into the execution, and I want to see what is the longest action. So I can see that there is an action here, which is get all the element of the first page. Okay, so this is the red sky. So I'm going into the execution. I'm looking for the red sky. And what I see here, this is actually the call itself. And the call shows me what happened right now. By the way, if I can see here, I can see that how much time it takes to execute each call. And here I can see what happened. I call to all the elements. And you can see how long is the response. I got a very long response for, oh, sorry. Actually, I wanted to go here. That's even more interesting. So I have this call that shows me how the page looks like, and you can see how much time it takes to execute this command. And this command is that get the first page, this is a JSON object, so if I'm going to open it as a JSON, you can see that I get an array of a lot of objects that arrive to my screen with all the details that I need to do. So I have hundreds of objects that download into my screen that contains the data. It takes almost a second, and this is only the main screen. This is the description. This JSON file is the description of the main screen. And another thing that I find here is that it's not that I am mobile, but again, it downloads a lot of details based on all the different area on the screen side. For example, this is under all the category what was being downloaded. I have to admit that this new page is much better than the oldest one that we are checking. And right now they're running just a JSON file with all the details, and then build the element based on the relevant screen and the relevant images exactly. But what you can see that the HAR file can help you to understand exactly what's being called and what happened behind the scenes. And if you're running your test against different devices, you can see that different devices get a different traffic over the internet, and then it can help you to find your slowest server. One of the interesting stories that I want to share with you, one of our customers had the slowest application. What we did, we executed the HAR file, and we found that his analytics data was so big, so it takes a lot of time to send the analytic data. So everything or all the page build ready like in a second, but then they need to wait 10 more seconds only for the analytic data to be sent.
So I think that if to summarize your point about HAR file, so the key benefit that I can extract from your session is that with HAR file you can optimize performance, user experience, and also get some insights on security of your responsive website, because you see the full traffic going back and forth. So I think that complementing both the functional testing, the visual testing that we already covered in this webinar, together with HAR file analysis, will definitely extend your test coverage. And we didn't cover in this webinar the point about accessibility that is growing, but I think that this will probably be in an upcoming event, because accessibility is definitely something that needs to be thought after, especially for responsive websites on mobile and web. And with that, we are exactly at the top of the hour. There are some questions which we weren't able to address, and we will follow up with all of you afterwards. I just want to highlight 2 giveaways for you guys online that joined this webinar. So from the Perfecto end, and we also shared through the chat panel a new refreshed ebook about testing responsive web that includes both functional testing guidelines, visual, and the HAR file consideration, but also many other insights that you can practice already today. So this is the ebook from Perfecto. From Amplitude side, we are also happy to share with you guys online I think an amazing masterclass, mastering visual test automation, a snippet of what Akrit was showing you, but taking it to the next level. And you have the online registration webinar on the bottom of this slide. And as Austin mentioned in the beginning, and she is also sharing with all of you in the chat panel, both links, we are going to share with all of you online the presentation, the recording, so we'll have very easy way to get access to these assets. And with that, I would like to conclude the webinar and thank Uzi for the great work and the demos you did today, as well as Akrit, VP Product at Amplitude. Thank you for joining us, Akrit. And thank you all for being here today. We hope that you enjoyed the content.
Thank you very much.
Thank you very much for having me.
Thank you, Akrit. Have a great day. Thank you all.